quantity squared.
Hold on 1 second.
Oh, okay.
Okay, go ahead.
Plus y minus 1 quantity squared equals 4. And they want the center and the radius.
Okay. Tell me what the standard format, the general formula for a circle is.
The general formula?
Uh-huh. You always want to start pretty much any kind of a math problem with the general formula, and then you can answer the question really easily.
Is that one where it's like ax plus axb?
That's the general, one of the general formats for a quadratic. This is the general formula for a circle.
Okay.
Where h and k are the center.
Okay.
And the radius squared. Okay, so this is a circle.
Yeah.
So, in our problem, what is h?
3.
Well, it's going to have to be negative.
Negative 3.
What's k?
Positive 1.
And what is r?
2.
Those are the three things they asked for?
Yeah, I think so, yeah.
Okay.
Because negative 3 is the x-coordinate and 1 is the y-coordinate?
Yes, of the center. In other words, if I wanted to graph that, there's the center right there. The radius is about 2, so it would look like that.
Okay.
But this general formula is always what you want to deal with, whether you're dealing with ellipses, hyperbolas, parabolas, or circles. You always want to start them with the general formula.
Okay. Okay.
Let's see, you're studying conic sections, all of them, right?
Yeah.
Well, before we go on to some more of your problems, let's talk about ellipses, because they're very similar to circles.
Okay.
And it's easy to memorize them. If you know what the general formula for a circle is. Notice that a circle is very similar to an ellipse.
Uh-huh.
Instead of one radius, it has 2. I mean, you can think of it as 2 radiuses. There's the long side, which is A, and there's the short one, which is B.
Okay.
Okay? And notice, just for the heck of it, that if B was the same as A, that would be a circle, right? And if B were the same as A, I'd be able to substitute one for the other, multiply both sides by it, and I would be back to my equation for a circle.
Okay.
Because this would be A squared over here, which is going to be the radius. So I find that a little helpful in memorizing these general formulas.
Okay.
Okay, and then as long as we're at it, let's talk about a hyperbola, which is also somewhat similar. Only difference between a hyperbola and an ellipse is there's a negative sign.
Okay.
Between the two. Also equal to 1. Okay? Now, with both an ellipse and a hyperbola, these general formulas actually are a little different. The general formula for an ellipse is a horizontal ellipse. But if I had an ellipse that was like that, a vertical ellipse, well, that measurement's always A, the big one. That's always b. And in the case of a vertical ellipse, the a would come under the y term, and the b would come under the x term.
Okay.
It doesn't happen with a circle because there's only one way a circle can be drawn, and that's as a circle. There's no orientation to it like you have with ellipses and hyperbolas.
Okay.
Hyperbolas look kind of like this.
Okay.
Okay. And the equation of the hyperbola is that. Okay. So at some point when you study all four of them, they will give you a polynomial and they'll say, what is this? Is it a circle, an ellipse, a hyperbola, or a parabola?
Okay.
Okay. But the core of all of it are these three general equations.
Okay.
Absolutely must memorize these. I mean, there's no getting around it.
Yeah.
Okay. So what other problems do you have specifically?
The next one was y plus 8 quantity squared plus x plus 2 quantity squared equals 72. And they want the same thing, the center and the radius.
Okay. So what's the x-coordinate of the center, which would be h?
-2.
Correct. In other words, the fact that the y is first and the x is second doesn't matter as long as addition is going on here. If this is subtraction, like you get with hyperbolas, notice directly above, then it does matter. In other words, if I had, let's say I had an hyperbola and it was y squared minus x squared, that would be a vertical hyperbola, not a horizontal one. So it would affect its orientation. But with circles, circles are pretty easy. H equals negative, -2. K equals -8. And R equals what?
Square root of 72.
And simplify that.
36 goes into 72 twice.
Okay.
And then 18 goes into 72, or 18 goes into 36 twice. So a 2 can come out, and that'll leave you with 18.
Okay. Here's one thing to keep an eye on. When you're looking to reduce radicals, hold on. What you want is to find factors where one of the factors is a perfect square number. Perfect square numbers being and the factor the most efficient way to do the simplification is to find the largest perfect square factor. You found it right off the get-go, square root of 36. You don't need to break that up any further. In other words, because 36 a perfect square, that's 6 root 2.
Okay.
Okay. There was nothing wrong with the way you were doing it. In other words,
that's a faster way.
Certainly break it up into root 4, which goes, 18, and then 4 doesn't go into 18, but 9 does. So I could do it like that. And then that would be 2 times 3 times root 2. So I get to 6 root 2 either way. But
the 36 is an easier way.
Well, you want the way that has the largest. In other words, if I was reducing this, the largest perfect square number is 100. So that
Yeah.
would be the square root of 100 times square root of 2, or 10 root 2. Well, I could get there half a dozen different ways. 4 is divisible into 200. 25 is divisible into 200. So I could do it the slow route. In other words, this is kind of the slow route, which always works, but if you found a larger perfect square number, then it reduces your number of steps to use it.
Yeah.
All right.
Okay.
So what else do you have there?
The next one has us put it in like standard form of the equation, so it doesn't start out in standard form.
Okay.
So the first one is x squared plus y squared minus 4x plus 8y minus 5 equals 0.
This is the standard format for a polynomial. Okay. For any of the conic sections. For parabolas, for circles, for ellipses, and for hyperbolas. They're all liable to come as just a polynomial. And for you to get it into the standard format, you need to complete the square.
Okay.
Well, our standard format is x minus something squared plus y minus something squared equals r squared. So the way we're going to do this is gather the x's together.
Okay, so x minus 4x.
Leave space to complete the square.
Mm-hmm.
Gather the y's together. Put parentheses around them.
Plus 8y.
And again, leave space. And then on the other side, put the number. Okay? Now you can see that we're getting closer to the standard format.
Yeah.
All we have to do is complete the square inside the parentheses, and we'll have pretty much the standard format.
Mm-hmm.
So, do you remember how to complete the square?
Yeah, I think so.
Okay, what do I want to add over here?
On the left side, we want to add 4 to the x's.
Okay, and the moment I do that, I
have to add 4 to the
equation, so I have to add 4 to the right side. Now it's the same.
Yeah. And then on the y, we want to add 16, and you have to add 16 to both sides.
Okay. Now how can I express this, what's in parentheses over here?
Becomes x minus 2 squared. 2 squared plus y plus 4 squared equals 25.
Now you have it in perfect format. You
You
know where the center is, and you know what the radius is.
Yeah.
Now, let me mention some pitfalls. Do you have some that are harder than this? It might just be easier to wait until... Are we doing all circles today, or are we getting into anything else?
Yeah, today's just circles. And yeah, I do actually have it's getting harder as it goes on.
Okay. I will just say one thing. If this was a negative sign, like that,
yeah,
you have to be very careful when you gather your x's and y's together. In other words, this isn't going to be a circle. That's going to be a hyperbola. Because hyperbolas have the two things that are being squared separated by a negative sign.
Okay.
When you go to put this in parentheses, you have to be very, very careful about this term right here. You have to change the sign on that term so that you do not change the equation. In other words, let me just, this sounds like I'm getting a little ahead, but not really, because this is a trap that almost everybody makes. In other words, here's what I'm trying to say. If I had this polynomial, They wanted me to get it in standard format. Start out same way. But over here, now notice that I can't just write y squared plus 8y.
Yeah. It would have to be y minus 8y?
Yeah.
Y squared.
Y squared minus 8y. Notice that this is the same as what is above. And that's the key on all of these problems, is as you go from one step to the next, you want to make sure you have not changed the equation. Okay? Oh, yeah. And if I remove these parentheses down here, I still have my minus y squared and I have plus 8y. So this is the same as that. But okay, most everybody I know leaves that as a plus 8y because it's all they think they're doing is adding the parentheses. Well, when you add parentheses, sometimes you have to compensate for the fact that what you are putting parentheses around is being subtracted, not added. So okay. Be very careful about that. Okay. And that'll happen only when you get the hyperbolas, because only when you're on the hyperbolas is there a negative sign either in front of the y squared or the x squared. In other words, okay, hyperbolas can be y squared minus x squared, but they're always separated by a negative. Okay. Okay. All right, give me another one.
Okay, the next one is 4x squared.
Good. This is
plus 4y squared plus 36y plus 5 equals 0.
All right. Notice something else, that if the coefficients of the x squared and the y squared are the same, it's a circle. Okay. If they're different, it's an ellipse. If this was anything other than a 4, this would be an ellipse. Okay. Okay? So that's the other thing about circles, is the coefficients of the x squared and the y squared are always the same. Now, if I gather, I only have one of those.
Yep.
Now, you cannot complete the square until you get the coefficient equal to 1.
Okay, I'm confused. What does that mean?
Well, first of all, I don't need to complete the square over here.
With the x term?
Right.
Yeah.
Well, let me think about this for a second here. Yeah, in other words, h is 0. Okay? I do need to complete the square here. But before I can do it, I have to factor out that coefficient, whatever it is. Leaving behind that. And notice, again, I have not changed anything. Every step you're checking. Okay? Now, complete the square inside the y parentheses.
It would have to be 9 halves.
Okay.
If you're half
9 halves.
9 halves squared would be 81 fourths.
Uh-huh. And it's much better to leave it in fractions than it is decimal.
Okay, yeah.
Now, when I wrote 81 fourths in there, how much did I add to the left side of the equation?
364.
Do it the easy way. Multiply the 4 times that 4, I added 81.
Wait, what? Sorry.
Okay. In other words, the moment I wrote in that,
yeah,
I added to the left side of the equation this amount.
Okay.
Because it's being multiplied by this 4 that I factored.
Yeah. Oh, it just becomes 81, right?
So I have to balance it on the
Oh,
other side by adding 81.
yeah.
Because I just added 81 to the left. And
Okay.
you don't want to do this by doing 324 divided by 4. You want to do it that way.
Oh, okay.
Okay. So now I have how do I write this?
Y plus 9 halves squared
Uh-huh.
equals 76.
And now what?
All right, the square root 76.
No, I'm very close to having the answer, but I can't have any
Oh,
coefficients in front of
do I
either
have
the x squared or the y term.
do, do I have to divide everything by 4?
Yes.
Okay. So dividing that by 4, 76 becomes 19.
And there you have it. There's your standard format for a circle. What's
Okay.
h?
H is 0.
K is?
K is negative 9 halves.
And r?
Is the square root of 19.
Which we know is simplified because it's prime.
Yeah.
Any prime number is not going to have any factors at all. So that's the thing you have to be really careful about when you're completing the square. That's another mistake that people make very commonly, is when they complete the square, they don't multiply it by that number they had to factor out.
Okay.
Okay? And you're always going to be able to get rid of these coefficients because with circles, they're the same, always. In other words, this 4 is always going to be the same as this number. Otherwise, it's not going to be a circle. It would be an ellipse. And then working with an ellipse is an entirely different proposition. But have you done parabolas already?
We haven't really touched on them. She said we were going to touch on them later this week and the next week. Parabolas, hyperbolas.
Actually, perhaps the hardest of the 4. Circles are certainly the easiest of the 4.
Yeah.
And parabolas, you wouldn't think they would be the hardest because you've been working with parabolas forever. In other words, the standard format for a parabola in vertex format is this. Well, I'm not sure how your school is going to handle parabolas because various school systems handle it differently. Some school systems will give you this as the standard form for your parabola when you're talking conic sections.
Okay.
And it's worth noting that these two are the same, and the thing that connects them is A is equal to 1 over 4P, or P is equal to 1 over 4A. They both mean the same thing. And P is the distance to the focus. So usually when you're talking conic sections for parabolas, the focus is the most important thing after the vertex. Whereas when you're talking parabolas with quadratics, a year ago or 2 years ago, they never mentioned the focus or the directrix or any of that good stuff. So the moment they start working with you parabolas as conic sections, they'll either give you this format as the general format, or they'll give you this one. And for years, I preferred this one. I thought it was rather silly that they spent 3 years teaching you a format and then immediately change it as soon as you get into conic sections. But you can see that as long as A is equal to 1 over 4P, how we go from the first one to the second one. In other words, all I've done is subtracted k from both sides, and I've divided by a, which puts the 4p there.
Uh-huh.
Okay. Now, if you can take whatever parabola you have and put it into this format, then immediately you can solve for p, and you know where the focus is. So just a little bit of a heads up there. When we do talk parabolas next time, probably, make sure you're aware of which format they're using.
Okay.
There's, you go to
Columbine.
Columbine, yeah. Chatfield, I've got students that are at Chatfield, and when I ask them which format they're using, they weren't sure. So try to find out the moment you get parabolas, or if you have a textbook, it'll tell you in the textbook. My textbooks all use the 4P format as the general format. Okay. But some of them use this top one, the vertex format that everybody knows already, and they just tell you that A equals 1 over 4P, which allows you to calculate P, given a certain A. All right. I'm jumping ahead because circles aren't going to give you a lot of problem.
Yeah. No worries.
You can give me a tougher circle problem if you want.
Okay, this one is find the equation of a circle having center on the line x minus y equals 5 and is tangent to the y-axis at the point 0, 8.
Boy, I wasn't kidding.
Yeah, they jump pretty quick.
No, I mean, I'm embarrassed that I said all circle problems are easy. So we have a circle. Let me get this straight. And its center is on this line, right?
Yes.
Okay. So let's draw that line.
Okay. I'm a little confused.
Well, let's put that in y equal mx plus b format and plot it. And then we'll know a little bit more about how to solve this problem.
I'm putting the
the top one.
So
that's a linear. That's the equation of a line, not a curved anything curved. Okay. So if I manipulate that, I get y equal x minus 5, right?
Yeah.
Okay. Well, how do I graph that?
The intercept is at -5 and it goes up 1 each unit to the right.
Okay. Something like that. So they're telling me the center of our circle is somewhere on this line. Okay. And there's also a tangent. What was the rest of it? A tangent to the y-axis?
And tangent to the y-axis at the point 0, 8.
Well, if I go to 0, 8, so does that mean that, in other words, you can't really be tangent to the y-axis, but the y-axis can be tangent to the circle? Maybe that's what...
I think that's what they're saying.
Okay. So if the y-axis is tangent to the circle, naturally I never have enough room here. Well, I think you can kind of see what's going to happen here.
Okay.
Hold on. The center of our circle, I'm trying to figure out if I can draw a reasonable model here to show you what's happening. Yeah, if the center, sorry.
That's okay. So the center is going to be somewhere at that 8 level.
Isn't it?
Yeah.
Because otherwise, now hold on a second.
Well, yeah. Doesn't the center have to be at some point of x, comma 8?
I tell you what, let me redraw this so that I can get the whole circle in here. Let me make this point 0, comma 8.
Okay.
I don't think it matters that our scale is different. What they're saying is that the circle is tangent to the y-axis at that point, and if the center of the circle has to be on the line, then there's a reasonable drawing of it, and none other would work.
Okay.
No other way to draw that circle other than that way. Not if it is to be tangent to the y-axis and its center is on our line.
And wouldn't the x-intercept of our line be 5?
Yeah, it would be. Yeah.
And so if it goes up by 1, wouldn't we just add 8 to our 5?
Well, no, I think this is a little more difficult.
Okay.
First of all, if I connect the center of the circle to this point right here, this is always a right angle.
Yeah. So it's going to be on the same y plane, right?
Well, if that's a right angle, then that's a horizontal line.
Yeah, so it's going to intercept at the 8 on the y-axis.
Yeah, let me think for a moment here. How am I going to come up with the equation of this circle? In other words, what you say is true is that that point is at 5, comma 0. But I don't know that that helps me.
I think wouldn't that help you, because if the line's at it's just it goes up 1 point for every 1 x unit it moves right on the x-axis. So wouldn't you just add 8 until you get to 8 for the x-axis? You'd add that 8 to the 5. So your center of your circle would become 13, comma 8.
Let's see. Yeah. No, you got a good point there. In other words, yes, if I go up so that this distance is 8, in other words, to get from there to there, do I know this point right here?
Well, the x-intercept is, no, we don't know the center.
Well, it's 8, for sure, that.
Yeah, yeah.
And you're right. For me to get up 8, I got to go 8 to the right. So I think you're correct. I think that is the center of the circle.
Okay, cool.
Only because we know that this line is a horizontal line, because it makes a right angle with the y-axis. Therefore, it has to be a horizontal line. Therefore, its y-coordinate has to be 8 also. And based on the slope, yeah. So now we know everything there is to know, I believe.
Yeah. Because the radius is the same distance as the x-axis, correct? If the circle is tangent to that point 8.
Well, if this is the center, that's 13 to the right.
So if you go 13 to the left.
13.
Yeah.
So what's our equation of the circle? Based on all this information.
X minus 13 squared plus y minus 8 squared equals the square root of 13?
It's equal to r squared.
Oh, so it's equal to 13 squared. So that would be 169.
Yeah. Now, just as a test, does that point lie on the circle according to our equation?
Which point? 0, 8?
Any point on the edge of this circle, on the circumference of the circle, has to fit this equation. Whatever my coordinates are, not the center, but on the edge.
Okay.
The only point I know of for sure that's on the edge is this 0, 8. Well, if you plug in 0 for x and 8 of y, does that satisfy this equation?
Yeah, because negative 13 squared is 169 and the y cancels out.
Right. Now, that's not proof that we have the right answer, but it's pretty good confirmation, and we don't have any other points on that, and we could figure out what that point was. How would I, well, the only way I could figure out this point and this point is to set the equation of the line equal to this equation of the circle and solve for those 2 points. But that doesn't really advance our cause. That assumes that this equation is correct. Do you have answers for this problem?
I don't know if she had answers for this specific problem because it was the challenge problem.
Well, I was going to say, this is one of the more challenging problems I've ever come across for circles. Sure, right after I say that circles are easy. But I think we've done this correctly.
Yeah, no, she doesn't have, yeah, I think so too, but she doesn't have an answer to this one because it's the challenge problem.
Okay.
So she usually just goes over these in class.
Okay. The key on these kind of problems, I think, first of all, is drawing a model of it. In other words, attempting a graph of some sort. And obviously, the very first thing you have to do is draw the straight line, which means you have to manipulate this equation so that you can put it in a format that allows you to graph it.
Okay.
And secondly, you have to know that the tangent line to a circle always makes a right angle to the line that connects the edge of the circle to the center.
Okay.
And that's what tells you this is a horizontal line. And once you know that's a horizontal line, and you know that your straight line has an x-intercept at 5, then you can use the logic you used, which was perfect. Actually, I'm very impressed. I'm not sure I would have seen that right away.
Okay, cool.
Yeah. And boy, it'd be nice if there were another way to check. We had another point.
No, the only point that we're given is 0, 8.
Yeah. In other words, clearly there's a point over here, 26, 8.
Yeah.
That also is on the line. And that also fits this equation. If you plug in 26 here, you still get 13 squared plus 0 squared equals 169. But again, that's assuming we have the right equation. There probably is another way to check to make sure our answer is correct, but I can't think of one right offhand.
That's okay.
All right.
Okay. The next one is find the equation of a line that is tangent to the circle x squared plus y squared equals 34 at the point 3, 5.
Very close to getting into calculus here.
Okay.
First of all, that's a circle with center at where?
0, 0.
Okay. And this point right here is what?
3, 5.
No.
Oh, that would be 0, comma. It's somewhere in between 5 and 6.
No, let's leave it as a root.
Okay.
And it's not 0, comma that, it's 30.
Oh, root
34. In other words, the radius of this circle is root 34.
Okay.
Which doesn't reduce, incidentally, because that's 17 times 2, both prime numbers.
Okay.
And they're saying find the equation of the line
that is tangent to the circle at the point 3, 5.
Okay. There is 3, 5. So if I plug that in, do I get, yeah, I get 9 squared plus 25, or 9 plus 25 equals 34. So that point is definitely on the circle. What we need is the slope of that point.
Could we plug that into y equals mx plus b format?
I was just getting ready to write that. Unfortunately, we're missing 2 variables. In other words, I could plug in 5 for y and 3 for x, but I don't know where b is, and at the moment I don't know what the slope is.
So could we plug that into the other format of that?
We're going to have to use the same principle.
Okay.
If I can figure out, I know what the slope of that point is. Yeah. First of all, can I figure out the slope of this line?
The line.
Radius line.
The radius line? Could you figure out the slope of that?
Yeah.
Wouldn't it be 3 over 5?
It's rise over run.
Oh, so 5 over 3.
Is it positive or negative?
That's positive.
Okay. Now, what's the slope of the perpendicular? Because our tangent line is perpendicular to that radius line.
So it would be...
That's the principle that's at play at both the last challenge problem and this one, is knowing that the slope of the tangent line has to be the negative reciprocal of the slope of this radius line.
Okay.
So what's the negative reciprocal of plus 5/3?
Negative 5/3 or...
Got to do 2 things. Always remember when you're finding slopes of perpendiculars, you got
negative 3/5.
You got to flip it and change the sign.
Okay.
Okay. Well, now we have enough information that we can figure out B. Okay, because we have the slope. That's what we're going to want to plug in for M. So now we have y equals negative 3/5 x plus b. And I know this point is on my line.
Okay.
So I'm going to plug it in for y and x, and that will allow me to solve for b.
Okay. So negative 3/5.
Now, let's stop for just a second.
Okay.
Are you familiar with point slope format?
Is that the one where it's like y minus y1
Yeah.
equal?
And the reason I ask is because clearly this is a precursor to calculus.
Okay.
What you're talking about here can all be solved easier with calculus, but notice that if I have y minus y sub 1 equals m times x minus x sub 1, this is called point-slope format. This is called slope-intercept format. Well, I can get my point-slope format immediately. I don't have to solve for b.
Okay. And she said it's okay if we leave it in that format,
That's
actually.
definitely okay. It's the preferred format. Okay.
Okay.
Notice I can get it in one step. I have a slope and a point. So using point slope, I have y minus y sub 1, which is 5, has to equal negative 3/5 times x minus x sub 1, which is that. And there's the answer. There's no simplification required. And that's why point slope actually is better for this kind of a problem. Notice that when I used y equal mx plus b, I had to keep going once I got the slope in order to solve for b. Which we didn't actually do, because at that point I realized, well, you need to know point slope, and you probably have learned it. It turns out that once you get to calculus, these are exactly the kind of problems you get. You're always trying to come up with the equation of a tangent line, and what you always have is a slope and a point.
Okay.
So the point slope format makes a lot more sense to use when that's what you have, is a slope and a point.
Okay.
Okay. So yeah, you wouldn't even want to simplify that. That's a point slope format is considered every bit as valid as slope intercept format. It's a little harder to graph. I'd have a harder time graphing it if it was in point slope format. But they're the same. In other words, I could clearly distribute this, move the 5 over, and I would have it in y equal mx plus b format.
Yeah, okay.
Okay. But again, the same principles were involved on this problem as were involved on the last one, and that is that the tangent line is always perpendicular to the radial line.
Okay.
And that perpendicularity allows me to figure out the slope of the tangent line, because I know it goes through the origin, so I know what the slope of this radius line is.
Okay.
And this point over here that I said was root 34 comma 0, completely unimportant, not needed.
Oh, okay.
At the time, I didn't know.
Yeah, it's okay.
But, I mean, a lot of times you just kind of, with some of these kind of problems, you're just kind of scratching around in the dark until you see something that, yeah, that's how I'm going to solve it.
Okay. Okay. I have one more problem.
Okay. We got 10 minutes, so that'll be just about right, probably.
Okay, so this one is x squared plus y squared minus 8x plus 12y plus 42 equals 0.
Okay. Now you might think that's going to be problematic, because when I move that 42 over the other side, it's going to turn negative, right?
Yeah, but that's not the whole problem yet. Hold on.
Oh, okay. Well, I was going to say you can't have a negative radius squared, but it's not going to stay negative 42, because as I complete the square, I'm going to be adding numbers over on the right side to balance it.
So it wants us to find the equation of a line that is tangent to that circle equation at the point 5 comma negative 3.
Okay. I believe believe we're going to have to get this in general format for a circle.
Yeah.
So that we can graph it. And then once I graph it, I can put that point on there and I can figure out, we're going to have to figure out the slope between this point and the center of the circle. And then we're going to have to take the negative reciprocal of that. Okay?
Okay.
In other words, the last problem was relatively easy because figuring out the slope of the radial line was easy because its origin was at the center. Well, it's going to be a little different. I'm going to speed it up a little bit here just so we can get to the meat of the problem.
Okay.
Don't have to factor anything out here. So I don't need to worry about putting parentheses around these. Only time you need to worry about when you're putting parentheses around something is to make sure that it's not being subtracted from something else. Okay?
Okay.
At this point I check, make sure I haven't changed anything. Now complete the square. I'm going to add 16 there
16,
and 16
and add 30.
And then I'm going to add 36 here. 36
and 36
there. Yeah, only reason I'm doing it instead of asking you for these answers.
Oh, no worries.
Is
we've been over this.
The end of the problem. And now I'm going to write that as x minus 4 squared plus y plus 6 squared equals 10.
Okay.
So there's the equation of our circle.
Yeah.
And now, let's see what happens if I try to draw that. Let's see.
Center is at 4, negative 6.
So 4 negative, how come I never have enough room whenever I draw my grid?
5, negative 3.
Okay, let's see. 4, negative 6 is right there. And it's a circle of radius root 10, which is approximately 3 and change.
Yeah.
So this is not gonna, 3 and change. So yeah, it's definitely going to be something like that. Okay?
Okay.
And now the point 5 comma minus 3 is on the circle.
Oh, could we use that the rise over run thing?
Well, yeah. In other words, this is the same problem as we just finished, except the center of the circle is not the origin. So it makes calculating the slope of the radial line a little more difficult, but not that difficult. In other words, that point is 4 comma minus 6. So tell me what the slope of the radial line is. Well, designate that as m sub r.
Rise over run, so it'd be up 3 over 1. So the rise would be 3?
Yeah, let's see. Plus 3. If I take that minus that, I get plus 3 over that. Yeah. So plus 3. So now we know the slope of that tangent line. So the slope of the perpendicular is what?
Negative 3.
Got to do two things.
Oh, negative 1/3.
That's the way to remember it, is to always remember you got to do two things. Because everybody wants to only do one thing. If you remember you always have to do two things, you can't really make a mistake. Because the only other thing you could do besides change the sign is to flip the fraction.
Okay.
Okay? So remembering you have to do two things. Now, we can put it directly into the equation.
Of that slope format?
Using point slope.
Okay. So it would become...
I know a point that's on that line. It's 5 minus 3, and I know the slope of that line. That's why it's called point slope. If you know the slope and one point, you can come up with the equation of that line. So what's it going to be?
Okay. Y minus 5.
Hold on.
Oh, sorry.
The y is the second.
Oh, the y is the, okay. Whoops. So it would be y plus 3.
Uh-huh.
Y plus 3 equals negative 1/3 x minus 5.
Yeah.
Okay.
Let me just say one other, that's your final answer there. If you forget the point slope, here's a good way to memorize it. Divide both sides by that. What do you get?
Okay.
You get slope equals rise over run.
Okay.
Okay. So if you're ever wondering, about any of these 5 terms that are in this equation, remember that when you solve for slope, it better be the difference in the y's minus the difference in the x's. Or, excuse me, the difference in the y's divided by the difference in the x's.
Okay.
Okay.
Okay. I think that was the last problem.
Yeah, no, that's a good one. Let's see. Yeah, we did have to complete the square and put that in the standard format in order to find the center of the circle. And I needed the center of the circle in order to find the slope of this radius line.
Yeah.
And that's usually the case. I don't know that I've ever seen a problem where they gave it to you in standard polynomial format and you didn't have to complete the square and put it in the general equation format for a circle.
Okay. Okay.
All right. Nick?
Well, thank you.
Always give me interesting problems.
Huh.
I will talk to you later. Let's see, you have another scheduled this week, don't you?
Thursday, I think, at 5.
Yeah, Thursday at 5. I'll talk to you then. Whoops.
Okay, cool. Thank you.
Let me back up Thursday at 5 is correct. Okay, sorry. I was on next week. I wasn't looking at the right.
Oh, no worries.
So, talk to you Thursday.
Okay, thank you.
Bye-bye.
Bye-bye.